In this video, we're going to look at the antiderivative of x to the negative 1 power, or in other words, 1 over x. So let's look at this. Let's say we have the antiderivative of 1 over x dx. Now, you can assume and write it as taking the antiderivative of x to the negative 1 power dx, and you can also write it such as this: ln x plus c being the antiderivative. But this is being a little too broad, and we can write it in a way to make it more specific, more understandable, because if you have this value here, taking the antiderivative of x to the negative 1 power, x cannot equal 0, because you don't want an undefined answer. If I can actually make an equal sign, let's see, equal, not equal, 0. And ln x plus c is x greater than 0. But we want to be more specific, because this answer here is a little too broad, because it's just specifying the positive x's. What about the negative x's? Well, we have a different way of actually writing this. Say we have the derivative, let's see, the derivative of ln x. Okay, well, we know that's going to be 1 over x. But what about if we had a negative value for x? We can always write it as ln absolute value of x. What about that? Well, this is actually a way that you can write the antiderivative of 1 over x. It's just putting the x in absolute symbols, so you can specify both x can be a negative value or a positive value. But let's look at a graph. Let's actually draw this to get an idea of what I'm actually going on about. Okay, let's see. We have this graph here. And I'm going to go ahead and draw the curve for ln x. It's going to be something like that. I'm going to go ahead and label that. Y equals ln x. And it starts here at 1. Well, if I can draw there we go, 1. Now, we have, this is going to be for x is greater than 0. But what about, what about ln of absolute x, which is going to be just ln of x? Well, we want to both incorporate negative and positive values in this. So what if we had, say, negative 1 as x? If we had negative 1 here, it's going to be the same thing, because if we took the absolute value of negative 1, say the ln of negative 1, then we're just going to have ln of 1, because it's going to be the absolute value, which is going to be a positive value. That's why this here is y equals ln of absolute x is going to be that there, because it's both this and this, because once you take the absolute value of x, you're going to get both. You can use both negative and positive values. And, well, maybe I should have made it more of a mirror image of the other side, but you notice that they both are mirror images of each other, but they never touch 0. This is what we're trying to specify, is that they won't be 0. They're going to be either greater than or away from it's going to be away from 0, both on positive and negative sides, if you take the absolute value of ln of absolute x. Now, if we took the derivative of, say, ln of absolute x, we're going to get 1 over x. Well, ln of x, but then when we take the derivative of that, it's going to be 1 over x. So let's look at the graph as 1 over x. And 1 over x is going to be approximately something like that, getting closer and closer to 0, but not actually touching it. So this line here is representing 1 over x. You can see that they're all almost mirror images of each other. They look similar to each other. You notice that one here, the spot here, 1, and 1 here is approximately at almost at the same place. Well, not according to my drawing, but take my word for it. So you can see they're like mirror images of each other. But you notice that they never touch 0. This is the point that we're trying to make, is that x cannot equal 0, but we want x to be incorporated as both, it can be both negative and positive. And the way we do it is just writing absolute value, or ln absolute value of x. That way we can incorporate both a negative number and a positive number.